What?
All right, so today let's review a bit about electric currents. So we did learn about the circuits, and in part of that, we have series and parallel circuits. Do you remember them?
Yes.
Mm. So, like for example, you have this circuit. Is it a parallel or is it a series circuit?
That's a series circuit.
No, it's wrong. It's a parallel one. Why? Because the flow of electricity will have to go from the battery here to the amp meter, and then it's split into two, right?
Oh.
There you go. It's split to two light bulbs. So go to two light bulbs. These two light bulbs are actually parallel to each other, isn't it? So
Mm-hmm.
it's a parallel circuit. How about this one? How about this picture?
Mm, that picture.
Yeah,
That's what what is it called again?
a
Uh,
series circuit.
yeah, series.
Why? Because here the flow of electricity have to go through the ammeter and go to the first light bulbs
Second light.
and go to the second one, right?
So it's series.
So they're next to each other and then it collects, go back to the battery here.
Mm-hmm.
Understandable? It's a series circuit here. Now,
Mm-hmm.
so can you tell me what is special about series and parallel circuit about the flow of electricity? So let's look at series circuit now. The flow electricity through the first light bulb is the same with the flow electricity go to the second one, right?
Mm-hmm.
It's the same flow. However, if you look at a parallel circuit, is it the same flow of electricity?
Where?
Yeah.
No,
It's not the same. Why? Why it's not the same?
because it's divided into two.
Because the first circuit, I mean, the first flow of electricity has to divide itself into two, and then it collects back here. So,
And there will be less
mm,
light produced.
so it means maybe the flow is divided by half of its strength, to go through the two light bulbs. Now, so they say in series, the current is the same at all points in a series circuit. But in parallel circuit, they have to be divided. So the sums of the different currents in the branches of a parallel circuit will be equal to the current entering or the current leaving the parallel section. Like for example here. Here, the current through this light bulbs
Mm.
plus the current through these light bulbs has to be equal to the current entering it here or the current leaving, right? Is it understandable? Yes or no? Or in other words, let's say the current entering here and the current leaving here must be the same. However, the current going to this light bulbs plus the current going to this light bulbs has to be equal to the one leaving and entering, right? Is it understandable now, Chloe?
Mm-hmm. Yeah.
All right. Now, let's talk about direct and alternating current. So, who was the guy? Who was the inventor who invented the direct current?
Who invented the direct current?
DC,
The
yeah.
the guy who stole. Oh no.
Yeah, also the same guy who invented the light bulb.
Yeah, the guy who stole the idea from light bulb.
Everyone said he steals things. What a disgrace. The name is Thomas Edison. Who's
Mm-hmm.
the guy who invented the alternating current? Who's the rival?
Also the same guy.
No,
The
it's
right
the rival of Thomas Edison, Tesla, Nicholas Tesla.
Nikola Tesla.
Okay, so
Okay.
what's the difference between DC and AC then?
Where
Okay, what's the difference between direct current and alternating current?
the difference between direct current and alternating current is the voltage is always
Second?
um uh is a direction in where
Hmm,
the electrons flow.
I say it's the direction where the electron flow. I agree. Hmm.
It's the direction, right?
Hmm. Because in DC, the electron flows only in one direction. It doesn't go back, right? But in AC, it just go back and forth, back and forth. It reverses regularly, right?
Mm-hmm.
The flow will be reversed regularly in AC. Now, okay, let's move to the next part. They say batteries only give you direct current. It only goes one way, okay? But if you have a generator, it can produce DC or it can also produce AC as well. Now, we have the next part is frequency of alternating current. Okay, let's talk about the word frequency. How do you understand the word frequent? Like, for example,
Frequency sometimes,
I frequently go
sometimes.
to the gym, for example. What does it mean? If I said, I frequently go to the gym, what does it mean? It means
That
I
means
often, it means I
often.
often go to the gym, right? So frequency describe how frequent an action is. Like, for example, let's just say that in 1 second, I do one action.
Mm-hmm.
So my frequency is 1 hertz. So the number of complete alternations or cycles in 1 second is called the frequency of AC. Like, for example, let's look at this one. The flow go up and then down and then up again. So it come back to the original point. So this is one cycle of an AC. So go up and then reverse, going down and then go up again. This is one cycle. So this is another cycle. Up, down, up again.
Mm-hmm.
So the time it takes to go one cycle like this is called the frequency of the
Mm-hmm.
AC. Okay. So the unit of frequency is a hertz. Hertz is actually a name of a German scientist as well. Hertz. Now, so we have figure 36.6 here. And you can see this is how many seconds. They say this is half a second. This is 1 second, right? So to finish one cycle here, you need only 0.5 second.
Mm-hmm.
However, to finish two cycle, you need 1 second. So what does it mean? So it means the frequency of AC in this figure is 2 hertz. Or it means there are two cycles per 1 second, isn't it?
Mm-hmm.
2 hertz means two cycles per second.
Mm-hmm.
Let's just say that you run, okay?
Okay.
If you do bicycle, if you ride a bicycle, and for 1 second, let's say you cycle like there's a one revolution of the wheel, or the wheel revolve one time.
Mm-hmm.
So your frequency is one hertz.
What does revolt mean?
Revolve means it swing around, rotate one
Oh,
rotation.
okay.
Never mind. Anyway, so basically, frequency here is 2 hertz, which means two cycles per second. Or if you make it like this, it can be one cycle lasts half a second. True. This one cycle is only half a second, you can see here. Now,
Mm-hmm.
the main supply in the UK is AC, a frequency 50 hertz. So what does it mean? In 1 second, there are 50 cycles. So you can see that the current, they changes its direction all the time and very fast, isn't it? And each cycle, 50 hertz, it means each cycle lasts only 1/50th of a second, very fast. This regularity was used in a ticker tape timer in chapter 2 and rely upon in main operated clocks and something like that. You don't need to know this. Anyway, let's do this question, okay? Now, you have a flood lamp. Ever know what a flood lamp is?
No.
This is a flood lamp. It's a kind of lamp, okay? And they say the current is 5 ampere. So what charge passes in 1 second? There is a formula to do this. You remember the formula we have here? Q equal to I times T. So Q is the charge in column passing through here. T is in second, and the current is ampere. So using this one, can you calculate this one? So what charges pass in 1 second?
Mm-hmm. Charges in a second.
How many charges pass in 1 second? If your current is 5 ampere,
5 ampere. Uh, let me see. Is it 10 seconds?
try again.
10 seconds?
No, I'm talking about 1 second here first. What charges pass in 1 second? So we need to really pay attention. Come on.
1 second?
Come on, we have a formula. Q equal to I times T. And here you are asked what charge passes in 1 second.
What charge passes
So
in
Q equal to 5 ampere times 1 second. So you have 5 column.
5 minutes? Oh, wait. 5 columns. So,
It's just applying formula. Now, how about what charges pass in 10 seconds?
uh, what charges pass in 10 seconds?
Mm-hmm.
Um, one?
Try
No,
again. Wrong. 10 seconds. Okay,
10.
now you have 5 ampere, put in there. And time is 10 seconds, you put in there. So what is 5 times
50 column.
10? 50 column. Very good. 50 column. How about in 5 minutes?
Mm-hmm.
5 minutes?
5 minutes is 25 column.
Wrong. Again. Remember, time is in second. You have to convert 5 minutes to how many seconds first? Do it.
Mm, 5. Sorry. Wait, but isn't it 25? I don't get it.
5 minutes. Each minute is 60 seconds.
Oh, so it's uh, what?
So you have 300 seconds.
So it's
300 seconds times 5 ampere.
1,500 column.
Good. 1,500 column.
Mm-hmm.
See, it is a very simple math, but you still make that mistake. Now try again.
I forgot.
Hey.
I forgot you had to do the seconds.
Oh, come on. You learn the formula. You have to understand the units. Okay, let's try again. 1A.
On
What
A,
charge passed in 1 second? Try again.
1 second. It's 5 column.
5 column. 10
Mm.
second.
10 second is 50 column.
Okay, let's try again and let's try again in 2 minutes. 2 minutes.
2 minutes. 2 minutes is um, 2 minutes is 120 times 5. That's 200. No, that's 600. No,
600 column.
no, that, yeah, 600 column. Yeah, yeah.
Now let's do number 2. They ask what is the current, which means they ask for the I. What is the current in a circuit if the charge passing each point is 10 column in 2 seconds? All right, so now you are given the Q, you are given the T, you have to find the I. They ask what is the current. Okay, you do it.
I current. What is the circle of people? Hmm. What is current and circle and charge? Crossing each point is 200 inch. Hmm. What is what is the current in a circuit if it recharges percent each point is the current. Hmm. Let me see.
How much is that?
Hmm.
They ask for the current, which is I, and you are provided the Q and the T already. So it means you have to convert
12
formula. So
per second.
Q equal to I times T. So it means I would be equal to Q divided by T, right?
Wait.
Is that true?
Oh,
And then what happened next? Put the numbers in. So they asked 10 column in 2 seconds. So the I should be
fine.
5 ampere. Remember the units. 5 ampere. Now try B, please.
B is 0.5 ampere.
Very good. C, please. Remember,
Uh,
2 minutes, not seconds. You have to convert.
it is 1 ampere, right?
No, wrong. Try again.
2 minutes is 120 seconds. So it's 2 amperes.
Correct. So it's going to be 2 ampere. Remember the units, 2 ampere. There you go. Now, number 3. You are asked to study the circuits in this figure 36.8. Okay, so you have A, B, C, D, and E. The switch S is open. So it means the circuit is broken. There's a break in the circuit at this point. So it means the electron flow won't go there. So at which circuit would lamp, Q, and R light? Okay, so light here is a verb, okay? It's a verb to light up, lit up. In which circuit would the lamps Q and R light, but not lamp P? So you have to think carefully. This is related to series and parallel circuits.
Mm-hmm.
Yeah, some time to think.
Mm-hmm. Which one?
No, you have to think.
Which one? Hmm. At P? No. In which could would lamp Q and R light, but not lamp P? In which circuit? Uh, but not lamp P. Is it the second one, like right next to B? I meant B. Is it B?
How do you know it's B?
Because when the electricity go through, no, Q and R have to light up too.
So it means,
So only Q light up, but not R.
no. They say lamp Q and R lights up. So these
I
two
know, but not lamp
light,
P.
but not lamp P. So it means that the electricity have to
Oh,
go through
no,
the
no,
Q and
no.
R first. You're
Uh,
correct. This is B, correct.
it's
But
P.
the explanation is wrong. It's very simple. Here, look at this one. The flow of electrons will have to go through a closed circuit, which is here. You can see my cursor. It goes through R and Q, right? So of course these two would light up and it go back to the battery. However, the flow of electron will not go through the S here. So it means it will not go through lamp P, so lamp P will not light up, isn't it? Same
Mm.
situation happens. Okay, so in C, let's look at the flow of electrons. It can only go here, but it's broken at S, right? So it means the electron will not even flow through R at all, let alone going through Q or P, isn't it? So in circuit C, everything will not light up. You understand what I'm saying?
Yeah.
Okay, so how about D here? D here is a series circuit. So you can say the flow of electron, okay, it will not flow because it has no escape, isn't it? Has no escape to go back to battery. So it means that all the three lamps will not receive any current at all, isn't it? So it means all of them will not light up in D. Do you understand it?
Mm.
Remember, the circuit must be closed and the current must receive an exit to go back to the battery. Okay? Otherwise, there won't be any circuit at all. Otherwise, there won't be any current at all. Okay? So for E, for example, you can see here at the battery where, okay, the flow, it cannot go anywhere because because here it's like broken. So there won't be any electricity at all to go through the three lamps. So all of them, darkness. Okay? Not light up at all. For circuit A, okay, you can see here, it's a series circuit. And the flow have to come from the battery and get out. But the problem is, it's broken here. And the flow has nowhere to go back to the battery. So there won't be any flow of electrons or current at all in A. So all three of these lamps will be darkness, no light. You understand what I'm talking about, right? Hello?
Yes, I'm listening.
But do you understand what I'm talking about?
Yes,
All right, so for circuit B, for example, you can see that, okay, the flow, they can go here and then pass through here and then go back to the battery, right?
yes.
So it means this little place here, this little circuit here can act like a closed circuit. It means there will be a flow of electrons through Q and R. So it means Q and R will light up. However, look at this. The flow of electron going through here, does it go to the S? No, it doesn't, right? Because here is
No.
broken. It's broken here. It means that light P will not receive any flow of electrons at all, isn't it? Even though there's an exit to go back, but lamp P doesn't receive any current at all. It will not light up. You understand, right? So circuit B actually satisfy the condition that a question give you. So B is a correct answer. You understand
Mm-hmm.
now?
Yeah, I understand it now.
Okay, great. Let's read this one. Number 4. Which of the
Number
following
4.
statement is correct? It talk about
Let
this
me
figure. Yeah.
let
Okay,
me
let's
read.
spend some time on it, okay? Read it, spend some time on it.
Using the simple and figure tradition when S1 and S2 are close, S1 and S2, S1, S2 are close, A and B is lit. No, and S1, mm, wait, that close means like connect or open. I forgot.
Say again.
Does close mean connect or open?
Where?
Does close means connect or open? I
Close mean
forgot.
they are connected.
Oh, close means connected. Uh, no. When S1 open, S2 close, S1 open, S2 close. It's not and S1 open. Is B correct? I think B is correct. It's either A or B.
So let's look at A now. When S1 and S2 are close, which means it's gonna conduct electricity, lamp A and B are lit. Of course, if S1 is closed, there will be a flow of electrons through A and also B. So, of course, these two lamps are lit, correct. But
B.
S2, okay, you don't need S2 to be close. If it's open or it's closed, there will be a flow of electrons through A and B anyway, right?
Mm-hmm.
So, but still, A is correct. Now, let's look at B. With S1 opens and S2 closed, they say A is lit and B is not lit. This is not true because if S1 is open, there won't be any current at all, right? To even go through A and B.
But
Because
B,
here, look, if S1 is open, there won't be a electron
I
flow
know.
through
So
S1 at
it's
all.
A and B only.
So it
A
means
and B.
that both of them are not lit. So B is wrong.
Wait.
Okay.
Oh.
And then
Oh.
C, with S2 open and S1 closed, AB unlit. Look, S1 is closed, okay? So there's a flow of electron through A and B. But with S2 open, it doesn't matter if S2 open or closed, right? It doesn't matter if S2 open or closed because there will be a flow of electrons through A and B anyway, right? In either case, yeah.
Mm-hmm. Mm, mm, with S2 open, S1 closed, S2 open, closed. S2 is not really needed, right?
Exactly. Doesn't matter if S2 open or closed. You know,
So
A and B
it's
will lit up anyway, will light up anyway, right? So answer A, correct. C, correct. B, not correct. You understand it right now? Yes or no?
mm-hmm.
All right, great.
Yeah.
Okay, number 5. Exercise number 5. If the lamps are both the same in figure 36.10, so it means
Where's
lamp, yeah?
can I read?
Yeah,
I
just read it first. Just read it first. Sorry.
internet both the same in figure 36.10. If they're both the same, and if I made sure A reach 0.50, another A, 2, 3, and 4 with emitter 1 with 0.50. Yeah, this one looks so hard. Mm, mm. Mm. It's so hard. I don't get it.
All right, so they say if the lamps are both the same, so this lamp is the same as this lamp, and you have 4 amp meter, okay? Remember, these amp meter do not consume electricity, okay? They're just there to measure, okay?
Mm-hmm.
All right. Now, ammeter A1, they read 0.5 ampere. They ask what do ammeter A2, A3, A4, A5 read? Like Okay, so let's first think about it this way. Where does the electricity go through first? Okay, it has to go through this way. Look at my cursor. It go up there and go through ammeter A1, right?
Mm-hmm.
And then it has to split into two. And because the two lamps are the same, what does it mean? It means the flow had to be split into two. So it means this circuit received 0.25 ampere. And this one also received 0.25 ampere. Is it
I
understandable?
see. Yes.
Right, correct. So, so how much does A2 and A3 reads?
A2 and A3.
0.25
25.
ampere, right?
Yes.
And
And the same
A4
for
and
A4 and A5.
A5, yes, 0.25 ampere, correct. You understand it now, no?
Yeah, I understand it
Because it's the
now.
same flow, right? Okay, it's the same flow that split into two, right? Yeah, so 0.5 split to 2, you have 0.25 here and 0.25 there, right?
Mm-hmm.
Okay, is it understandable now? Quite easy, right?
Yeah,
Okay, I'm
it's
glad
easy
that,
after you explain it.
yeah, you're lucky to have me. Because I'm both very patient and I know how to explain. Okay, now let's move on to the checklist. Okay, can you read the checklist, please? After studying this chapter, you should be able to do what now here?
Mm. Define unit. What did you say again? I
Okay,
didn't.
just read this. Just read this. Like what you should
Okay.
be able to do after studying this chapter.
Hmm. 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 Yeah, I'm done reading.
Now, okay. All right. So unit 37, we talk about potential difference, okay? Okay, so since we learn about current and the flow of electrons, we'll talk about potential difference now, which is 175. I'm just writing down. Okay, so we'll talk about energy transfer and potential difference, model of a circuit, the volt, cells, battery, and EMF, electron motive force, voltages around a circuit. Mm. So we know what is ampere, like how strong is the current, right? And we talk about how many electrons, the charge is the column going through the wires, right?
Yes.
Now, so let's read this one for a moment. A battery transforms chemical energy to electrical energy because of the chemical actions going on inside of it. It builds up a surplus of electrons at one of its terminal, negative. And of course, it creates a shortage as the other, the positive one. Remember, conventional current going from the positive side to the negative one, right? But in practice, in truth, the electron have to go from the negative side to the positive one, right? Of the battery. Do you remember that?
Mhm.
Of course, electron flow, it has to flow from the negative one to the positive one, right?
Yes, of course.
Yeah, but people back then, they didn't know. So they still use the old convention. They say that, okay, the flow of electricity have to go from the positive to the negative one. I mean, you need to know those facts, okay? So this is exactly what it says. Okay, it is then able to maintain a flow of electrons, or in other words, an electric current in any circuit connected across its terminals for as long as the chemical actions last. So it means that a battery will not last forever. You know that, right? Like, for example, you have a 9 volt, 1.5 volt battery. Let's say a battery like this. After some times, it will die, right? And it will not work anymore. You have to remove and replace it, isn't it?
Mm-hmm.
Because the chemical reaction in there, they will not last forever. It reacts, and then after some times, the reaction will stop, and there will not be any electron flow at all. And that's when you need to throw the battery away and put a new one in. That's what it says here. Now, the battery is said to have a potential difference, they say PD, at this terminal. So imagine, okay, let's imagine here. This is a positive, this is a
Mm-hmm.
negative side, right?
Mm-hmm.
So the electron will concentrate itself around the negative terminal here. And there will be very little electrons here at the positive one, isn't it?
Okay.
And the differences between the two sides of this battery, it's called potential difference. Okay, is understandable?
Yeah.
It's like in one room, if here you have 10 people and here you have 0 people. So the difference between the two is like 10, isn't it? Okay. Now, the potential difference is measured in volts. Okay, like 0.5 volt, 1.5 volt, 6 volt, 9 volt. Like, I think in Singapore, do they use 110 volt? Or is it 220 or 224 or 240? Let me check. It's fun. What voltage is used in Singapore? They say that, okay, so in Singapore, you have different types of sockets here. Oh, wow. These are British, right? They follow the British system, yeah. Oh, wow.
Uh, in Singapore, it's type G. They only use type G.
Ah, yeah, I saw these things before. It was super annoying.
I hate it because like in Ho Chi Minh, they always use type C or type F.
Yeah. I mean, it's like impossible to, you need an adapter, of course. Okay, but they say that, okay, the standard voltage in Singapore is 230 volt at a frequency of 50 hertz. And
Mhm.
how about in Saigon? It's 220 and 50 hertz. So it's a little bit lower.
Mhm.
Okay, but you know that in other countries, let's just say in Japan, they use 100 volt. It's weird, right?
Mm-hmm.
So if you import, like, let's say something from Japan and you plug it in to the Saigon uh, socket, that item will die immediately, right?
Yeah. Wait, so if
Explode. It will actually explode, or heats up and die.
wait, so if you use an what is it called? That
Adapter. So you
yeah,
need like some
adapter.
kind of adapter, yeah.
Yeah, if there's adapter with 5 holes, then that means it will separate electricity, right?
It depends, but you should definitely use your appliances that say, let's say, 220 volt in Vietnam. So most of the thing imported from Japan, they have to rewire it back to 220. Otherwise, if you plug it in, the device will explode or it will heat up and it will be destroyed. You have to rewire it. Okay. Otherwise, it's dangerous. All right. So volt is the unit for potential difference. Actually, it's the name of another guy. And the term voltage is a noun for volt. And it's the term voltage is sometimes used instead of potential difference. Now, have you ever seen a car battery?
Mm, which are
Okay, this is
better?
a car battery, okay? It's inside of a car.
Mm-hmm.
All right, and they say the car batteries here, they say potential difference of a car battery is 12 volt.
My eyes so hurt.
All right. And the domestic main supply in the UK is 230 volt.
230 volt.
Okay. You know what? I think it's better if you if you just leave now and then try to sleep or something. I think your eye's hurting, right?
Yeah, it's like water coming out. Whenever like it's like it like my eyes keep squeezing and then where there's water.
Okay, let's just tell mom that you should take a break now.
Okay,
Okay, so I'll see you on Monday, okay?
okay.
Same time like five
No,
o'clock, right?
5 o'clock Vietnam time.
Mm.
Doesn't change.
And remember that I do not take breaks during the Lunar New Year, so we can still study.
Wait, Lunar New Year is like next week?
No, Lunar New Year is actually okay. It's I think it's on the
Fifth or
no, no, no.
wait,
The
let me check.
first of okay, the 1st of February is actually the first day of the Lunar New Year. Lunar New Year.
It's 29th January. January.
No, no, no. The 1st of February is the first day of the Lunar New Year as well this year.
Mm-hmm.
I say. But remember that on Monday, this Monday, the 3rd of February, we can still study.
Mm-hmm.
I mean, I'm still here. Anyway, I'll see you then.